Welcome back to the SDG Warriors Podcast. I'm Simar Mohanty, the team lead and student coordinator of the SDG Warriors. We're a team of passionate student change makers and STEMnists on a mission to meet the United Nations Sustainable Development Goals by 2030, leveraging the power of STEM education and 21st century skills. Brought to you by us SDG Warriors. This podcast features inspiring stories of edu heroes and STEM experts from around the world, ideal for students, teachers, parents, and pretty much anybody interested in STEM education and social impact. This podcast aims to drive enriching learning experiences and positive change in local, global, and digital communities. Imagine a world where conversations with animals are just as normal as talking with your best friend. Just like in the movie Arrival, Dr. Louise Banks decoded the mysterious language of heptapods. Today, we are going to be in conversation with the real life Dr. Banks, Miss Pratyusha Sharma, who is breaking down the vocal language of the ocean's own gentle giants, sperm whales. A little bit of background: Miss Pratyusha is a PhD student at MIT's Computer Science and Artificial Intelligence Laboratory and a key researcher in the Cetacean Translation Initiative. Also known as Project CETI, these fantastic individuals are applying advanced machine learning and state of the art robotics to listen to and translate the communication of sperm whales. Pratyusha's research centers on identifying intricate patterns within these whale vocalizations, particularly codas, to explore the potential for language like structures among non human species. And prior to her PhD, she completed her bachelor's degree in production and industrial engineering from the prestigious IIT Delhi, where she contributed to robotic projects, including those aimed at enhancing education in developing countries. And her interdisciplinary background, including merging biology, artificial intelligence, and engineering, positions her as a key contributor to Project SETI's mission to unlock interspecies communication and pave the way for a deeper understanding of marine life. I don't think I could be more excited for today's conversation, Ms. Pratyusha. It's an absolute honor to have you on a podcast.
No, thank you, Simar. It's absolutely an honor for me to be here. It's really great to see what you're doing.
Thank you so much, Ms. Pratyusha. And before we dive into the questions, to help our listeners audibly visualize the entire experience, can you tell us where are you right now? What is the weather like outside? And what can you see from your window?
So I'm on campus at MIT, and I'm sitting in this small like reading room slash library. It's early in the morning, so nobody's here, and I can see some trees outside.
That sounds great. It was like a warm and sunny day here in Bangalore, India. Now it's around 6:30 p.m. in the evening, and before going live, I enjoyed some delicious Mangalore budgies. Looking out of the window, I can see that it's the typical Monday scene with people on their evening commute. You can see cars moving along, and the hint of those Monday blues in the air, which is very different from the blues that we are going to be diving in today. So
Yeah.
now that we have that picture painted, let's begin with the questions. Ms. Pratyusha, you've had a strong engineering background ranging from production and industrial engineering to robotics. So, before diving into Project SETI, what sparked your passion for understanding interspecies communication, and how did your work in robotics and AI evolve into including decoding whale vocalizations?
Yeah, that's a really nice question. And the answer, actually, it was really luck. So when I started grad school here, my advisor, Professor Antonio Torralba, he asked me if are you interested in understanding whale communication? Um, and I had when before I started grad school, I thought I'll work on a few projects involving robotics. I was very sure I wanted to do robotics and nothing else. And I had already thought of what I wanted to work on. But I thought about it a little bit, and then it occurred to me that, understanding the communication of another species involves understanding what kinds of goals are important to them. What kinds of things in their environment do they choose to communicate about? What kind of protocols do they have, when they're doing all of these group coordinated behaviors together? And all of these seemed a little bit like problems in robotics that, I had thought about or wanted to work on. And it felt like a problem that maybe I, like, as someone with a background in robotics or AI, could start to think about. And other than that, I really like animals. And I think when I was a kid, I was pretty sure I wanted to be an environmentalist. So I felt like, it was bringing a lot of different things together. And uh, it was just, I heard that uh, it's actually such an intriguing question, right? Like, how do you even go about understanding the communication of another species, and that too in the wild, not in captivity, where you teach them, a fixed set of new symbols to use. So it was just a really intriguing question. I didn't know the answer, and I just wanted to work on it, I guess. So that's how.
Absolutely. I mean, listening to how your passion for robotics uh, evolved into evolved into something as fascinating as decoding whale communication. I mean, that's truly inspiring, Miss Pratyusha. You know, during our early years, when we are choosing subjects for our senior secondary years, there's this clear-cut advice for science that you can choose PCB if you're interested in medicine or life sciences, and choose PCM if you're interested in engineering. But what if you want the best out of both worlds? I mean, listening to your story is such a refreshing reminder for our student listeners that you don't have to be boxed in. The possibilities are endless when you blend your passions, just like you did, Miss Pratyusha, by following your love for robotics and then going on to use it in such a meaningful way to help animals, bridging the communication gap between humans and whales through machine learning and biology. And I think this is a perfect example of how tech for good and how interdisciplinary research is transforming our world. And this brings me to Project SETI. Miss Pratyusha, how did Project SETI begin to decode sperm whale vocalizations? And could you explain it like you would to a 12-year-old?
Okay, yes. So Project SETI, just for some introduction, is this really large organization. It's a non-for-profit organization with scientists from around the world. Okay, like people based out of MIT, Berkeley, people in Dominica, at Harvard, like many different universities. And these are scientists with very different backgrounds. Okay, so computer scientists. Engineers, cryptographers, roboticists, linguists, right, mathematicians, and really like how Project SETI started was that there was a group of scientists. So Professor David Gruber, Professor Shafi Goldwasser, and Professor Michael Bronstein, right? So they were at a workshop at Harvard where they met each other, and I think they like one of the I think Professor David was like listening to the sounds of sperm whales, and I think they had a presentation. I'm not exactly sure what happened, but I think together they wondered if it would be really cool to start to study the vocalizations of these animals, right? Because it sounds a little bit like Morse code. We have no idea what they're saying. And then they kind of put together the rest of the team of people from different universities to start to study sperm whales. Um, and like, how did we begin to decode sperm whale communication, right? So Project SETI has so there's a biologist whose name is Dr. Shane Giro, who's part of Project SETI, and he was kind enough to share this really large database of vocalizations and behavior that he had collected for 20 years of sperm whales in Dominica. Okay, and so that really gave us like a starting off point to even start looking at preliminary questions to, like, how would you even like, what are even the right questions to ask, right? So some good questions to ask is like, what aspects of their calls are they choosing to encode information in, right? What is it that they're choosing to talk about? How are they structuring longer sequences of calls? What are the protocols of dialogue? So, we started looking at some of these questions using some of this older data set. But then simultaneously, one of the issues with how data was collected previously was that scientists would have to go out on a boat, tag whales, and you'd get like 1 day of data. Okay, now you cannot go out every day in the ocean. Some days you're not going to find the whales, right? So what Project SETI is doing is also building the necessary hardware to, have round the clock recording, right? To build a larger data set, to build a multi-sensory data set. So that's really how we begin. And now I guess, with all this new data that's coming in from all of these different sensors, um, hopefully, we'll be able to ask like richer questions or maybe harder questions even. But yeah, I think that's how it started, and that's how we even, like begin to approach this question.
Absolutely. Listening to the early beginnings of how Project SETI started was amazing. And to give more insight for our listeners, could you tell us more about codas and how the phonetic alphabet of whales come about?
Yes, for sure. So basically, looking at the Dominica sperm whale project dataset, which was Dr. Shane Giro and his team's dataset, like previously it was believed that sperm whales in Dominica, or like the Eastern Caribbean one clan, they produce like a fixed set of 21 types of calls. Okay. And they kind of make this one, like they start out by making one call and they pretty much keep repeating the same call over and over again. Right. So um, but at the same time, they exhibit fairly complex behaviors. Like, they coordinate babysitting each other's young ones, they coordinate diving together. They even coordinate sleeping at the same time and so on. So basically, there was this kind of conundrum, right? The communication system is so simplistic, but the range of behaviors that they're able to exhibit is so complex, and all of this in like complete darkness at times, right? So it was not fully understood how are they able to facilitate such complex behaviors with such a simplistic communication system. So one of the things that we found was that basically, if you were to look at their calls in the wider communicative context, right? So by that, what I mean is earlier, like calls were looked at one at a time, right? But actually, if you place them alongside other calls that were made, how they were responded to, right? One thing that becomes immediately obvious is that there are these fine-grained changes in how a call is produced over longer periods of time. Okay, but that doesn't tell us if it's actually, significant or important to the whale itself. But another thing we see is that some of these fine-grained changes are perceived as well as imitated by other whales in the exchange. Okay, so like if it really was noise and not important, why would another whale even respond to it? And more so, like even pick up on it and make the same change to their own call. Another thing that became obvious is that they're able to do this kind of selectively, right? So there are a lot of examples in nature for how animals imitate each other's calls. Okay, like even in crickets, for example, they sometimes match up each other's calls. But what was interesting here is that they were only matching up to one feature of their call. So they're not copying the entire call. They could be saying two different words, so to say, but like match up like each other's tone. Okay, so that was also interesting. So there were like these longer range like features that are important to the communication, which became important in the wider communicative context. And there was a selective control that they were able to exercise of the different features in the calls. So what we found was that basically, like instead of 21 fixed calls, there was like this unknown this variation that was not previously known about, that whales are able to exhibit, right? And their call system itself is what is called a combinatorial coding system, where every call is assembled by picking from a set of features, right? And why is this interesting? And also, like, to give an example, so if you think of the Egyptian writing system, right, where there are hieroglyphics, every symbol maps to a meaning, right? So now if you want to represent a new meaning, right, like a new type of word, you kind of want to create a new symbol for it, right? But now in the alphabet writing system, like we have a fixed set of alphabets, but we can sequence them together to form words that map onto meanings, right? So basically, the idea is the same. So, like you now, what we're saying is that there is this smaller set of like features that they're able to combine as they choose to give rise to these words that can be then mapped onto meaning and like words. It's very loose, a very loose analogy, but um, it's called codas, and then they also sequence these codas. So there's also like this bi-level combination in how they produce their calls. So yeah, that was the discovery, and it was very exciting because what it showed was that one, the information carrying capacity of their communication system was really underestimated before, and in principle, their communication system is capable of carrying a lot more information. So that was very interesting.
Right. So this reminds me a lot about what we studied last year in class 12 in bio. It was a lesson called Molecular Basis of Inheritance, in which we learned how scientists deciphered genetic code, just like you're doing with whale communication. We
Yeah.
learned that we have these codons. So codons, these sound similar to codas in whale communication. So
Yeah.
codons, these are like sequences of three nucleotides that code for amino acids. So just like in the genetic code, we have a language where nucleotides like A, T, G, C, they come together as letters. They can be thought of as letters, and codons are the words, and together they form these sequences of codons. They form sentences which are known as genes. These
Yes.
provide instructions for building proteins. And I can draw parallels of how, similarly in whale communication, these individual voices or clicks, they can be seen as letters or phonemes, like you described, Ms. Pratyusha, and how these codas can form words. And these sequences of codas are act as sentences which can convey complex messages, which are imitated by other animals. Is that a correct analogy?
That's a great analogy. That's just such a beautiful analogy. And it's true because, like, the genetic code is also a combinatorial coding system. And actually, there, like, even if we, even if we leave sperm whales out of this for some time, like, even the language system, right? Like, it's so interesting how many parallels there are between the language system and the um, how genetic code represents like different messaging patterns. So there's like all of this hierarchical discrete structure in many different places in nature, and it's really fascinating why the same thing shows up so many times in so many different ways. Yeah.
Indeed, like the approach that people use to decipher the unknown, thinking that it remains same across concepts. It's truly fascinating, Ms. Pratyusha.
Yeah.
So, like, let's dive into this interdisciplinary approach a bit. Ms. Pratyusha, you're working at the intersection of biology, linguistics, and AI. How do you integrate knowledge from such diverse fields into your research?
Okay, so I think so it's definitely, so this project is very very interdisciplinary. But one thing that I've learned as part of this project, but also I think in life in general, is that at times you will not know everything, and there will be many such times. What's good about these times is that those are really the times when you get to learn a lot, right? When you put yourself in a position where you don't know things, and you kind of are forced to pick up new things, right? So I had no background in biology and no background in linguistics. And I think through the course of this project, like I think, I started to think more about, linguistic, like some topics in linguistics or some topics in biology. And really, I think, so how do you integrate knowledge from such diverse fields in your research? So at the heart of it, right, we are trying to solve, not solve, we're trying to ask a question and we're trying to find answers to that question, right? Um, and maybe you don't even need all of biology and all of linguistics and all of AI to even approach this question. So really, how we're integrating knowledge is, by looking at what the question really needs and kind of uh, learning whatever is necessary and trying to. And sometimes, that also gives you a little bit of. It's not totally a disadvantage because sometimes you come in with like no priors and no preconceived notions about the questions you're asking, so it can help sometimes. But how are we integrating? I think part of it is, we have a team of people from different fields So that really helps. um, Another, I think, I think I'm just learning on the go. So it's not, and sometimes it's working out, sometimes it's not. But nonetheless, it's like very exciting. Yeah, I kind of gave you a non answer, but how do you integrate knowledge from such diverse fields? Yeah, I think it's just in the process of asking the question, you realize what you need to learn and you kind of pull that in and, like, you read more about it, try to understand. And these fields are how, we slice up science, right? uh, we slice up this world in two pieces that we think are easy to manage and need to be studied individually, but actually they're the world is just presents itself as one. And uh, yeah, I don't know, I think these are just, you just have to try. And sometimes it works out. You have to learn a lot, it's fun. And yeah, one thing I can say is it's fun. And yeah, this is not a very good answer, I think, but okay.
No, it's an amazing answer. I mean, finding the right question before finding the right answer, it's so
Yeah.
important. And like
Yeah,
you mentioned, the world is a collection of different perspectives, of different people.
exactly.
You don't need to be a master in everything. Just be a
Exactly.
master at one thing that you're good at, and then find a team of people who are good at their own things. So yes, when these perspectives come together, it can shape amazing innovations like you guys are doing at Project SETI.
Yes, and I think also the willingness to learn. So this is one more thing I've seen. So like all the different people in the team are like very excited about learning about, like, other people's fields, trying to ask questions, like start right from like it's also like a good teaching opportunity as well as like a good learning opportunity. So I think it's overall really fun.
Absolutely. Having a growth mindset, that's the key.
Yes.
Well, moving on to the next question. Ms. Pratyusha, what specific AI and machine learning methods have been most useful in decoding the sperm whale communication so far?
Yes. So for example, in the paper that we had talked about a little bit earlier, right, where we find that there are these few different types of features, and within each feature type, there are few different variations, right? So for some of that work, we used a lot of methods from unsupervised machine learning, right? So like clustering, but I would still say that paper was a little low on using, very more advanced machine learning or more advanced AI methods. But we have another paper that'll soon be out, maybe on archive, where we are building sequence models of these whale calls, right? So trying to say, what is the whale going to say next, right? Who's going to speak next? What are they going to do next, right? So like basically some of these questions, right? Where some of the I wouldn't say the exact same, but like similar technologies to what are used to build, like, sequence models of language, right? So like ChatGPT, or like, some of these things that have become more mainstream. So building like these not building large language models, but building like these smaller uh, vocalization models of animal communication. So like mostly, so mostly things from like supervised machine learning, using learning to build like sequence models or language models. Um, yeah, so I think that has been very useful.
Definitely. I mean, like you mentioned, these models of unsupervised learning algorithms, they can, process lots of data. And a lot of times, like we've learned in 10th standard, that a lot of times that the data that is fed into these models, they are unstructured. And I think that this data may be far from neatly organized. So thinking that biological data often lacks the structured nature of typical ML data sets. Ms. Pratyusha, could you tell us what adaptations or innovations has Project SETI made in applying ML to such unstructured data, and how do you make ML work with this level of complexity?
Yes, so that's a great question. So, um, I don't think like all biological data is unstructured, and like not like, I feel like it can be fairly um, clean, and I think the data we are working with, uh, I mean, it's definitely, it's true, like it's not as organized, well studied, like a lot of data sets we see in machine learning, right? And when suppose you look at data sets in natural language processing, you can look at the data set and say, okay, this is what this means, this is the output, it makes sense because so and so. But here, you know nothing about this communication system. You don't even know where to start, right? And even if you build a model, like a sequence model of these their calls, it's not going to mean anything to you, right? Because you don't even know what this communication system, when even if it's correct, like of course you can compare it with respect to ground truth, but when it's making mistakes, it's harder to understand, what's going on. Um, so really, I think the adaptations of so one, like a lot of this is required, like coming up with new algorithms, coming up with new methods of like evaluating how good your models are, right? And really, like this question of like where nothing about this communication system, how do you go about like piecing out what aspects of the calls matter? So this is something that with we're studying currently, and like the paper that I was talking about maybe looks at this question a little bit more. But basically it has been it- so how do you like take these sequence models and then isolate what aspects of the calls matter, right? So the many things you can do. One thing you can do is throw out that information and see how that affects prediction, right? um, but basically, like I think it's been a combination of like coming up with the right algorithms, coming up with better ways of evaluating models that you build over this kind of data, but also like learning what might be the, like the paper that I was talking about earlier, where we find what aspects of their calls they could use to encode information. So trying to understand like this really high dimensional data, like what aspects of it are they able to control, and what's like a simpler representation of this data itself, right? So trying to structure it, so like given this audio, what kind of features you want to extract out of it that you can then use for any downstream task. So it's been a little bit like a combination of a lot of these different things.
Absolutely. I mean, handling such unstructured data like whale sounds, I can imagine it must be super difficult. And your team's innovation in adapting to that machine learning to process that complexity indeed makes me super inspired. And it makes me wonder that when using AI to to study whale communication, how does Project SETI ensure that the models are capturing genuine patterns of communication rather than coincidental or random associations? And like, how do you distinguish the meaningful communication from the noise in the data?
Yes, so this is actually a very important question and one that we're still trying to figure out. So for different aspects, right? So for example, if you want to say that a certain feature really matters in it like affects a thing that's going to follow, right? Or an action that's going to follow. Now we can establish like just by looking at these data sets offline that there's some correlation between these events, right? But how do you say that this is what is causing something like the like whatever are going to happen next to follow, right? So some of these things are harder to establish like from a totally non-interactive kind of setting, right? So but there are a few different ways. So like for example, in the thing that I was like where I was talking about how there's like this gradual fine-grained change in the call, right? Now how do you establish if that is real? How do you know if it's actually being used to communicate information or not, right? We don't know what information that they're communicating with that signal or that gradual change in the signal, but we do know that another whale is responding to it, right? So we can say just by looking at this wider communicative context, effect it has on other speakers, effect it has on behavior. We can establish that there is some pattern to like the call that's being produced and the effect it's having on another speaker or the behavior. So there's a way to kind of establish some like the fact that it's important, right? But to like kind of get to the questions of what meaning it's carrying, how is it causing this effect, what is the net result of this kind of thing. So some of the questions are still harder to answer. So I think we are chipping away at it like little by little. And yes, I think, some of these things we have to be very careful about, what we say, because uh, y- like, you have to, of course, be very careful with all of your experimentation. Like, you have to make sure that, the signal that you identify is actually informative, because, there could be other factors that could, like, how the whale is moving, that can cause some of this change. So we also make sure we find out these other factors, right, and make sure there's no correlation or effect of those factors. So that's how we kind of isolate, what might, what could, who's controlling this variation and what effect it has. So, that's roughly what we do.
Absolutely. I mean, even when we talk as human beings to our friends, it's not just about the words that we use. We often look at the body language as well, if somebody is mirroring us. So, looking at that, applying that same concept into whale communications is a way that you're able to see if the patterns are genuine communications rather than just incidences or random associations between things. And this also links to a previous point that you mentioned, that at times AI isn't a magic fix. It needs like constant refinement, it needs testing, and it needs validation. Because
Yes,
yes, so as AI is like interpreting these results, it's not always true, and it's important to be cautious because it made it at the pattern, but it doesn't mean that it's always meaningful. So that
exactly.
builds upon your point, Miss Pratyusha.
Yes, no, that's so true. Yeah, I think there is definitely still like a lot of like human selection, and like, being careful and like validating some of the results. So yeah, absolutely.
And on that note, let's now explore the ethical aspects of conducting such a large scale research. Ms. Pratyusha, machine learning models often rely on large data sets, but collecting this data from whale habitats could disturb the natural environment. So, how do you balance the need for data with minimizing the ecological footprint of Project SETI?
Yeah, this is also a really nice question. Yeah, all your questions are so nice. So, yeah, so I guess like one of the things that we're doing is, so there are many ways in which you can collect this data, right? Like, and there are many ways in which, so, so for example, like a lot of times when people like collect uh, uh, vocalizations or audio data from animals, they like attach a tag to their skin. Okay, now there are many ways in which you can attach this tag. Like you could have something that's slightly more invasive or something that's totally non-invasive. So at every step of the way, I think what Project SETI is trying to do is always choosing like a less invasive path to collecting the data. So for example, the tags that they deploy on, attach on the whales, they have like a suction cup that just like sticks onto the whale, rather than affect the skin of the whale in any way. So, that's one thing. It's a lot harder to deploy these tags, because you need the necessary suction, the whales underwater. It's harder to like, get that in water. But still, like, I think, we're opting for some of these methods. The other thing is like a lot of the recordings are going to be based off like buoys or recording systems that are set up like away from the whale. So they're just floating in water, right? And if the waves choose to hang out near it, great. If not, well, they're doomed. But mostly like the waves kind of hang out in that neighborhood, so that works out. So again, that is very non-invasive. The other things we're doing is we have drones that fly over these whales at a fairly at big enough distance that it doesn't affect the whales that much. Of course, like I don't think still we can say that we have zero effect on the whales, the lives of the whales. But I still think we're going for like as minimal of an effect as possible while still trying to collect the data necessary to conduct the study. So yeah, I think it's like actively making these choices every step of the way. And I think Project SETI is very, very careful about this. So, yeah, I think that's one way.
That's indeed so heartwarming. Like, when we talked about using these biologging tags which are non-invasive, using buoys and using drones to study those whales from far above. That's a great way to ensure that the ecological impact on these whales is not that much. Of course, there's going to be a little impact because we are exploring their environment, we are exploring their territory. But what's the best way that we can minimize this? Keeping that in mind, innovation doesn't always have to come at the cost of nature. It's
Yeah.
always up to you if you want to minimize the effects.
Yes, exactly. And in the process of like answering one question, we do not want to create problems and like other ways. So, it's very important to take care of these things. Yeah.
And this also ties into the point, like you mentioned, about having different perspectives on board through your team. Like you have lots of
Yeah,
marine biologists who can like guide and provide different perspectives on how, like, a certain thing that you want to implement or something that's planned to go live in some time, how it can have, what all impacts it can have on these animals, and how we can minimize it. So that also.
exactly. Yeah, that's such a great point. So that's very true. I think, people who worked very closely with these animals are also very sensitive to um, what can affect their lives, what kind of long-term effects can some of these things have. So, they've been like a guiding light through every decision that SETI makes. And I think it's really wonderful to see all of the, like, how this plays out and how different decisions are made. But yeah, that's basically how it's done.
All right. Well, Ms. Pratyusha, Project SETI is indeed a technological marvel. But are there any concerns that AI could misinterpret or decontextualize whale communication due to its lack of empathy or emotional intelligence? And if that's the case, how do you bridge that gap?
Yes, so misinterpret and decontextualize. So I think um, this is true for how humans kind of approach any system, right? We go in with our set of like priors of, oh, what does this mean? What does this mean? Maybe they're talking about the water, maybe they're talking about the fish, right? So we go in with like all of these priors about like, what might the whales be talking about? And once you have like these really strong priors that the whales might be talking about this or that, or you kind of might build that into your system somehow, right? So there is always a chance. But yeah, I think it really comes down to like, at least from what I see, I think everybody in the team is very careful about what they build into like what kinds of priors they build into their methods, how should the results be interpreted. And since it's a really big team, it's also nice to like talk to people and like tell them about your results. And yeah, so there's so mostly I guess it's like as a team everyone's very careful about what they say, if there's sufficient evidence, is this an effect of the priors that we're going in, or is this really something that's happening um, in the real communication system? And yes, so like I think it's always possible, but you have to be very careful. Yeah.
Absolutely. Context does matter. And like tech can be really powerful, but again, it has its limits, especially in terms of areas requiring empathy. And how we can bridge that gap is by bringing in human expertise, like you mentioned, Ms. Pratyusha, being careful every step of the way to ensure that there's not a single mistake in interpreting what these whales might try to communicate.
Yes. Yeah.
Well, right. So, working on something that has never been done before, Project SETI applies ML to non human communication. And thinking about that, we were curious, has there ever been any unexpected or mysterious discovery in whale communication research that sort of shifted your direction or focus on the project?
mm, so let's see. So, for example, one of the things that happened recently, it was unexpected. I don't know, like, I think also maybe mysterious, is that, we had never seen the birth of a sperm whale. It was never recorded. It was seen by multiple people, right, in the past, but it was never really recorded on camera, right? So, coincidentally, that day, I think there were people on the boat that were like, had drones up in the air, And suddenly, they spotted a little bit of blood, and they're like, oh, looks like, turns out it's, whale giving birth to a calf. um, and I think this was very unexpected, very new, very mysterious, because nobody knows what happens during a birth. And yeah, that has shifted the focus a little bit, but I think we still like, so for example, we're trying to understand what's going on when the um, whales giving birth to a baby, right? The kinds of calls that they're making, are there's just so much more chaos in the water. They're making all kinds of calls and they're talking so much over one another. So like really understanding what's going on there, how that's either helping them regulate different behaviors has been something that we're looking at. But yeah, and I guess the other thing, like when we found that there was this fine grained change in their calls. We also found how there was like this extra click that they sometimes like append to their calls, right? So like how it's almost like adding a suffix to a word, right? And then we saw how a lot of times when this extra click occurs, it occurs very close to like the beginning and ends of turns. So there've been like a few of these times when something popped out in that just became very clear in the data, and then it kind of directed what questions we asked thereafter. So those have been a few. Yeah.
Well, that was such a beautiful moment, and it really shows that the mother and the child relationship is so important when you're studying these different species. And surprises like these in research can actually lead to even greater breakthroughs. And we SDG Warriors can't wait to listen to all of the breakthroughs that you guys investigate, explore, and build through this dynamic project SETI. And talking about dynamics, like let's speak about gender dynamics. Miss Pratyusha, with the matriarchal structure being so central to sperm whale societies, do you think there are distinct gender differences in communication? And how might the communication in female led groups differ from that in males? And how do you guys at Project SETI aim to explore these dynamics?
Yeah. So that's a great question. So like you rightly pointed out, sperm whale groups or pods or societies have like this matriarchal structure. And the males that are born in the family, they leave the family. They go out on their own, try to find mates in other groups and so on. But and even the dialects or their calls are passed down, like the matrilineal lineage, right? So we have not really investigated this question in a lot of detail, but what I've read and heard from the biologists and the team, like from Dr. Shinjiro, for example, is that a lot of the male sperm whales are quieter, the female sperm whales are like chattier, Um, what are other gender differences in communication? So it's actually not very clear, and we've not, in all honesty, we've not really looked at this question very seriously. A lot of the data that we have is mostly from the female sperm whales, the spot of sperm whales, but sometimes there is a male, but usually they're very quiet. So um, I think it's just that's all we know for now. But I think going forward, this will be very important to study. Does this mean like when it goes to like a new group, does it also pick up the dialect of or the calls that the other group was making? Because the sperm whale communication system is something that that animals the baby learns over the course of its life. It's not a communication system that they're born with. So yeah, I don't know, is there like this kind of learning of a new dialect in adulthood that's displayed by maybe the male sperm whales? Like what do they understand about these new groups that they're talking to, that they're interacting with, like not talking to, but so yeah, it's not clear, but I think it's a very interesting question going forward.
It indeed is super interesting. And like you pointed out, I think it's just like with humans when we are babies, we learn our mother tongues. So sperm whale calves probably learn their whale language from their moms. So
Yeah.
I can imagine like these female-led groups, they might have a lot of chatter about food or safety or navigating
Yes.
different areas. It's just out of imagination. But males, they often might travel like in bachelor groups, or they might have conversations about competition or mating or finding new territories. So it indeed
Yes.
opens up many new questions.
Yes, absolutely.
Well, Miss Pratyusha, how do you foresee Project SETI's revolutionary interspecies communication research affecting animal conservation efforts? And what potential impact could this work have on how we protect marine life or approach environmental conservation today?
Yes. So, um, yeah, so maybe, what I can say here is, so earlier, like so Project SETI had, uh, Dr. Roger Payne in the team, right? And like maybe a little bit about him. So Dr. Roger Payne was along with um, Dr. Katie Payne. They found how, and also like other scientists, they found how like whales sing songs, right? And this was when nobody knew, like that. So basically, people put like microphones or hydrophones in the water. Like it was usually the defense organizations, and then they would pick up on this really weird like signal that didn't sound like it's coming from a man-made structure. And slowly they realize that it's actually whales that are creating these melodies, right? And over time, after this was found, like people realize that these are probably, and some of these melodies, like they really like um, affect you. Like when you listen to it, it's hard to explain how your mind feels or how you feel. It almost feels like yeah, it doesn't feel like noise in nature and so on. It's more structured. It's very beautiful to listen to. And I think that got people to realize that maybe these are complex animals. They've complex emotions. They're mourn. They're dead. They live in these packs as a tight bond between the mother and the calf. And clearly, like we should not be killing whales, right? And this was something that happened, I think, in the 1950s, or and all but two countries decided to like ban whaling, right? And yeah, so I feel like that was one example where a discovery really shaped how different countries build the necessary policies to affect and even accelerate conservation efforts. Right now, what impact can we have? We actually don't really know to start, but maybe something similar is what you could wish for, right? Like maybe just realizing that what how complex can their communication be, how they coordinating in groups. Maybe that makes us realize that they're even smarter than we thought. The kinds of intelligence that they display is like very different than us. Maybe some of these things can kind of hopefully like make, and maybe there are other things also, right? Like a lot of sound, there's a lot of sound pollution because of ships in the ocean, right? Because a lot of goods go from one country to another, and they take all of these routes that even whales use in the ocean. So it's like even looking at slowly starting to look at the impact of that on their lives, like will make us realize, how much maybe you and I sitting at in our office or at home, maybe we don't even realize it, but we already have so much of an impact on marine life. So hopefully, like in the course of this project, maybe some of the findings will a make people appreciate nature more, and b realize the kind of effect we have on it, and the effects short term, long term, and hopefully like the example of Dr. Roger Payne, maybe we'll also slowly get people to realize. But you never know with these things, so yeah, hopefully. Yeah.
Indeed, like bridging the gap between science and conservation is like so important,
Yes.
especially in today's world. Like machines are growing more intelligent, And by understanding whale communication, I think that we could get more insight into what they think of how humans are trying to destroy their environment, like the bad effects that humans have on the marine life. And when we have more insights into their needs and behaviors, perhaps we could do better in protecting marine life. And there was also a point that you mentioned about redefining intelligence. So, in a world where machines are becoming more and more intelligent, do you think that decoding whale communication could change our relationship with animals, or could it redefine what we consider intelligence in non-human species?
Yes, absolutely. So I think the way I think about intelligence is, it's not one axis, right? Like this is more intelligent than that, than this. Like, we cannot actually place everything on one axis. Every species has its own kind of intelligence, its own kind of problems that it needs to solve in order to survive, right? Its own kind of uh, adaptations to like fit to like find the best solution to the whatever ecological niche it's in to kind of do the best, right? So almost every species is intelligent in its own way. Like of course we have this perception that oh, humans are also intelligent, most intelligent on the planet, right? But we actually don't um, it's actually not saying much, right? Like of course we do see that we build all of these different technologies, we have a language system, but we also don't fully understand other animals yet, right? So I feel like one intelligence is not one axis, right? So I think even getting you know being able to find like what are these other types of intelligent behaviors, and even like coming up with like a better definition for what we consider intelligent or not, or maybe it's not even important, but just realizing that um, every animal has adapted to its own ecosystem so perfectly, found the best solutions um, for, and just like for uh, just learning more about them like tells you so much about nature, potential solutions to problems that we have encountered in our lives or we encounter as a human society. um, so hopefully there is, I think there's definitely a lot to learn. What we learn we don't know, but I definitely think there's like a lot to learn, and hopefully that'll also change how, like your question says that will it change our relationship with animals. um yeah, I hope so. I think people are in general becoming more sensitive about like what they eat and so on. But yeah, I think the human population is large. The behaviors as a society are sometimes unexpected, so it's a bit hard to say what effect it's going to have. But hopefully, like definitely, maybe all of us will learn a little more, and we'll see how that plays out, and hopefully, like more positively. Um, yeah.
Absolutely. As humans, even I agree that we often have this egoistic tendency to think that we are at the pinnacle of intelligence. And that's a bit short sighted and sort of ridiculous, because we don't even know what the other animals are saying, how they communicate with each other, how their societies function. And whale communication, for instance, like you mentioned, it could shift that perspective. Like you described whales, especially sperm whales, they can have highly complex social structures which can be more nuanced, and perhaps they have these emotions, which they have these different sort of emotions that perhaps we cannot interpret. They have different types of strategies which is not similar to the ones which are used in human civilization. And like you mentioned, survival of the fittest generally requires intelligence, so you can't compare one animal species to another, because everybody is on that way of survival. So yeah.
Exactly. Yeah, that's so well put. Yeah.
All right. So we were talking about intelligence. Let's talk about human intelligence now. IIT is India's most prestigious education institutions, while MIT is recognized as the top university worldwide. Students of both IIT and MIT often juggle extremely high expectations. So, Ms. Pratyusha, have you ever witnessed or experienced burnout? And what tips would you give to students who are going through a similar phase or nearing burnout, having questions like, what's the point coming into their minds?
What's the point? I'm sorry.
They have these questions in their minds like, what's the point of doing anything coming into their
I see.
mind?
I see. Okay. Okay. Yeah. Okay. So I feel like both at IIT and at MIT, I've seen like students are, they have extremely high expectations of themselves also, like they want to do better, like, they want continuously want to do better. They're not satisfied with what they do. They don't take time to like enjoy what they've done, or like, I think I also a lot of times like that. But Yeah, I think everybody experiences a little bit of like, questioning what they're doing, whether it's even meaningful, like, or just being tired at times, when you've just worked a lot and you're like, okay, the times, not everything will work out. um, yeah, I feel like I have experienced one thing I've experienced is also like fear, I think, of not knowing what's coming, not knowing what will happen. So I think everybody experiences it, and I'm no different. So, I've also experienced it. Um, so I would say, but one thing you can do is like, what you do once you feel, uh, fear or burnout, or like, anything you might call it, right? Like, one thing you need to do is make sure you have like a very nice system of um like, you have a nice support system around you, like, your family or your friends or your colleagues, advisors. And I think, yeah, that I think that is the most important thing, like having people around you who are respectful yet supportive, and can catch you when you're in like that kind of a phase, and like, and also like, I think even a little bit of like self uh, um like discipline, and knowing that, like, one, like, you're doing all this work because you enjoy doing it, right? And not forgetting that, the moment it becomes like less fun and like, tiring, then it's no longer what, you're not actually any longer doing what you thought you would like, it also makes the whole process a little more painful. So like, basically having some discipline, like, making sure you spend time exercising, having, social life, getting enough sleep, eating good food, and then, also just having more balance, I think, helps in general. And having a good support, uh, supportive circle of people around you also really helps. Yeah, other than that, I think, you should take the time to take a break when you feel necessary. It really helps, also gives you perspective when you come back. Now, it's very different for different people, but, just know that everyone feels it, and everybody, the only thing you can do is know how to handle it. There's no escape. But also, like, over time, you just get better at handling um, stress, or like, and yeah, I think you just feel more and more in control. You realize what's important in life, what's less important, and yeah. So I think that's, I'm also learning, like everybody else. So it's a lifelong thing.
Absolutely. Lifelong learning, having a support system, and like remembering your why, and having empathy for yourself as well. I think
Yes.
that's a big takeaway for all our student listeners today who are currently managing academic pressures, who are preparing for their entrance exams, and who have these big dreams that they want to achieve, but somewhere down the line they feel like they're not good enough. They have that imposter syndrome in their minds. So definitely your advice was like that tap on the head that it's all right. Everybody faces this thing, and sometimes it's good to take a breath, to stop what you're doing and focus on mental health. Have a, like, talk to your friends, talk to your parents, and then things will be back on track when you understand why you started this, because whenever you do something with passion, it comes naturally.
Yeah, absolutely. And I think another thing is, a lot of times, all of some fears can also come from lack of preparation, I feel. So I feel like, just making sure you're not slacking off like all the time, and then, just feeling the stress in the end. And so, I think it's a combination of these things. So yeah, I think it's, yeah, absolutely.
having that discipline is definitely key, and
Yeah.
something that we all students master through a course of time, not
Yeah,
immediately.
yeah, absolutely. Yeah.
Right. So, Ms. Pratyusha, having worked with both MIT and IIT Delhi, how do you think that the academic cultures of these places influenced your perspective on interdisciplinary research? And for us school students, what are some practical ways that we can cultivate similar experiences during our 11th and 12th grade?
Yes. So I feel like both at so actually IIT Delhi and MIT, I felt like were very similar in many ways and also different in a few ways, right? So actually, when I started working on robotics, it was at IIT Delhi, um, in Professor Subir Kumar Saha's lab in the like program for autonomous robotics, and it was with a friend who was in electrical engineering, and both of us wanted to do something fun together, and that's how really we did our first robotics project. Um, so so what did I see? So I and as Oh, so academic cultures in these places. So like basically, one thing that I've noticed is, um, you know, there are a lot of people. Like everybody is very smart, right? But everybody's also very very hardworking. Like they kind of put their head down and they just do the work. So I think that is one thing that is true for almost all the students I've seen, like at IIT and at MIT. But I also think that you'll also see that people are like very driven and they really like what they're doing. They're not just doing it because somebody told them to do what they were supposed to do. So I think there's a mix of that. Um, Other than that, I think by and large most people are like very curious about like a lot of things. So like to read a lot, like all the general, I'm saying very general things, but these are basically, this is true, like people are curious, people like to do the work, and they really like what they're doing, and it's like a combination of all of these things, um, that affect like your how you actually conduct research, what you end up doing. And on interdisciplinary research, I feel like both of these places, I think there's the necessary infrastructure and the necessary like monetary as well as like technical and support in place to conduct this kind of research, right? So not all labs at IIT did a lot of interdisciplinary work. There were like few labs, but they had the necessary infrastructure. Now imagine not everywhere in the world it's going to be true, right? So I think either work starting uh, like first whatever you have access to, like just starting somewhere, and slowly working through things that you enjoy, looking at what you have access to, and slowly like changing what you have access to over time, um, is one thing that yeah. And I think interdisciplinary research, um, from what I've seen, I think like one of the things that I said earlier also is that you will not actually know everything about everything anyway, right? There will always be these gaps and holes in your research. So, this willingness to learn and put yourself out there, like start from scratch, is something that is very important. Yeah.
Absolutely. Those are some wonderful gems for our young listeners out there to put your head down and work and stay curious. Seek out different opportunities, looking at the access that you have to different facilities. If you have a question in mind, like this happens a lot of times with me and many of my friends, that we are attending one class and then we think that there's a connection of that with a previous class. And sometimes we get like, because we are so busy in our work, we don't often approach that question, but that's something that should be minimized. We should follow up on that question, ask teachers questions, form a group of curious friends to I don't know, explore that question, and then go to our labs to research about it. And something that worked for us as SDG Warriors was to start a student club to explore our curiosity, because in this world of social media, it's really the beautiful thing about it is that you can connect with experts from different fields all it takes is to ask them questions and ask if you're ready to help with it. And definitely for students out there, you can even start a student-led club like we SDG Warriors did. And you may never
Exactly.
know, like you may never know what amazing discoveries might come through by staying curious and working together.
Yes, yes, absolutely. Yeah.
Right. So, well, Miss Pratyusha, it was quite fun having the conversation with you, and we've covered a lot of ground today from your work at IIT Delhi and MIT and transitioning to Project SETI. We covered a lot of ground on the different things Project SETI does, of how it's decoding whale communication, and we also covered the ethical aspects and how it's reducing its ecological impact. So now, are you ready for a rapid fire round, Miss Pratyusha?
Yeah, okay, let's do it.
All right. First question firing up. Imagine if sperm whales had a favorite music genre. What do you think it would be and why?
I think it would be beatboxing, and it's because they kind of that's kind of the call that they put. They sound very similar to beatboxing, or at least some sounds that people produce when they beatbox.
You ever beatbox, Miss Pratyusha?
No, no, I do not have that kind of a musical talent.
That's awesome. Like back in time, like I mentioned this on our episode with Dr. Kayla, that I had beatboxed in my class and how it turned into how it was like an embarrassing situation, but at the same time a good learning experience. It was like one of those things that I'd done because my friends pushed me to do it, because at the end of the day there are some friends who push you to do the things that you really don't want to do, but again it turns out to be a great learning experience. So
Yes.
yes. All right. So next question, Miss Pratyusha. Other than Arrival, which sci-fi movie best represents the future of AI in your view?
So I'm actually not sure if Arrival represents the future of AI very well either, but I think there's this movie called 2001: Space Odyssey, which is like a really old movie, and a lot of things that they showed in that movie kind of uh, it's a really old movie. Okay, so like some of those things you can see are starting to be a little bit true. Like some of the technologies seem to look or resemble those showed in the movie. Now, I hope it doesn't represent the future of AI because it doesn't end very well. So, um, but yeah, I think some of the things that they show in the movie seem to be around us already. So and I really like that movie. So yeah, I think maybe that movie.
Definitely 2001 Space Odyssey. That goes into our watch party playlist.
Great.
Well,
Yeah.
Miss Pratyusha, if you could give whales a gift from humans, what would it be?
It would be less noisy oceans. That would be the gift. Like I don't know how we could do that, but yeah, that I guess I could give any gift. Yeah, it would be that. This
That
is
would
such a good question. Yeah, but I guess that's what would be most useful. Less interference and a less noisy ocean. Yeah.
indeed peace. That would be an indeed a beautiful gift for whales, Miss Pratyusha. And on that lovely note, I noticed that today we've talked a lot about, like you mentioned, Project SETI and how it began decoding whale vocalizations to the complex methods that your team is using to understand these with ML, and your journey as an inspiring research scholar. Listening to all your insights into how Project SETI could redefine our relationship with animals have been truly eye opening, and it's been such a meaningful conversation so far. So, as we come to the end of this episode, let's wrap up all the learnings and takeaways in our last segment, the Inspire segment. Miss Pratyusha, who or what has been your biggest inspiration in life and why?
Okay. So I think the biggest inspiration in my life has been my parents, actually. Um, I think in many ways, like I think both of them really enjoy what they're doing. And they're also like just very curious people in general. Every time I talk to them about something new, they have so many questions to ask. And they really care about nature, even when I was a child. And even now, like, they really like animals. And I think a lot of the reason why um, I like I kind of care about nature is from them. Like my mother really likes watching birds. And even as a pet, like, we never even as a child we never had pets, because they were really against having animals be in a very restricted environment. um, and we would like rescue animals from outside. There's a lake near my house, so there'd be a lot of turtles and so on. But yeah, I never had a pet. um, so basically, I think in a lot of ways, like in how they approach their work, how they're curious about things, and also like how they treat people around them, and um, things they value. I think in a lot of ways, I think they inspire me. Yeah, and also like I think scientifically, like very much. I think right from the beginning, but yeah, I think that would be the answer for me.
Indeed, like our parents are those role models who would, inspire us to become the best versions of ourselves in whatever we do. So,
Yeah.
yes, indeed. Miss Pratyusha, what words of inspiration were given to you that you would like to pass along to others?
Okay, I think this question, I think I've given lots of words of inspiration and life in general. And I think I've given a lot of words of inspiration throughout this, like maybe a lecture almost. But what did I like to pass along to others? Yeah, I think, uh, make sure you're having fun. Uh, Very important. What else? Yeah, I think two things, maybe mostly. Like one, I would say, don't be afraid and be a little bit like fearless, with everything in life. Like, don't get scared. I think at least, and maybe I'm telling myself, like, be a little bit more fearless in life. Like, don't worry if you don't know about something. You can always learn. The other thing is, I think you should be a bit kind to people around you. So I think it's being fearless yet being kind, and I think that's yeah, maybe, yeah, these are not words of inspiration, I guess, but I hope everybody lives by them. Yeah.
They're indeed truly inspirational, and we can have that as a thought for the day, to be empathetic, to be kind, and to have fun, not miss out on life, and at the same time keep on learning from different experiences that we have while taking risks and being fearless.
Yes, yes, absolutely.
And coming to the last question for the day, Ms. Pratyusha, could you give us a call to action? What can we, children and young people, do to make the world a better place?
Okay, yeah, so I think this is a very good question. Because I've never thought about this, but now that I'm thinking of it, um, what would the call to action be? So I think one thing I would have loved to know as a child is, if you think there is something you want to do, don't think you cannot do it just because you're a child. Okay, so like I think a lot of times, at least maybe in the society we like I grew up in, and maybe you're in. Hopefully, it's changed a little bit, but like, I think there's a way like people will say, okay, you're a child, can't do this, or you're not everything, of course, but like there's some things that I feel you can do more of as a child, like read a lot, talk to like a lot. I feel a lot of what you're doing, Simar, already is very very interesting, very cool. Yeah, exactly. It's a be more like summer, I guess. Uh, so I think just, read a lot, like try to learn a lot. And yeah, I think to make the world a better place, like try to realize, like, what kinds of biases you have, right? And try to, like, ask yourself, like, where is this from? Like, why am I thinking like this? And, like, I feel like already, a lot of kids are, or young people actually, make sure you're reading a lot, but also make sure people around you, uh, yeah, are growing, and help them out, and yeah, just um, and carry that with yourself. Like, don't let that go away as you grow up. So I think that would be the advice. Yeah.
Definitely, Miss Pratyusha. That's like an incredibly impactful message for our listeners today. To not have any echo chambers, and to build upon our conversation, have multidisciplinary learning through different forms, and at the end of the day, to be a good and kind human being. What you said is basically the ethos to be, like, of being the change that you wish to see in the world, because at the end of the day, if you won't do it, who else will? And age or gender or any such sort of thing should never be a barrier to, creating change and making more, having more discussions and asking questions about different things. So definitely, that's an incredible way to wrap up our conversation today. And Miss Pratyusha, I can't thank you enough for joining us on today's episode. Like, from the start, listening to your journey of exploring things from Project CETI and ML and decoding sperm-based communications, and how, your research has may lead to a future where we can talk with whales and vice versa. I'm like awestruck by your incredible work, and truly, as STEMness, you're a role model for all of us at SDG Warriors. So thank you so much once again.
Oh no, that's so kind of you, and also it's such a pleasure to be here. Yeah, I'm very excited to see everything that you do. And yeah, I'm yeah, just very excited about everything you do, and maybe watch more of your episodes. And thank you so much for having me. It was such a pleasure talking to you.
Completely. It was an absolute honor to have you, Ms. Pratyusha. And to all our listeners, we hope that this conversation has sparked your curiosity about the complex and often hidden worlds of whale communication, and how, like, innovation in tech can bridge the gap between species. So whether you're a student who's intrigued by AI's impact on bio, you're a budding scientist who's passionate about marine conservation, or just simply someone who's interested in understanding how we might one day speak whale. We hope that you had a rich learning experience and gained valuable insights into interdisciplinary research and the importance of connecting it with our natural world. For the first time in history, advances in tech have made it possible to understand communication of animals, and you can tag along Project SETI's adventures by heading to their website, projectceti.org, present in the show notes, as well as explore Ms. Pratyusha's research from her GitHub page, which is also present in the show notes. To deepen your knowledge of everything STEM, sustainability, and education, subscribe to the SDG Warriors podcast for in depth discussions and meaningful conversations with leading STEM experts like Ms. Pratyusha, who are shaping a better world, decoding one coda at a time. If you love this episode, help others find it by leaving a review and sharing it with your friends, teachers, and family. Stay curious and be the change. Until next time, it's bye from the SDG Warriors.
Bye.